So let's talk about subtractors and comparators. Subtractors are, well, similar to adders. We perform the function a minus b, and really that's a plus a negative b. We can think of it that way. And so how do we take a 2's complement number and negate it? Well, we flip the sign, we take the 2's complement. And so this minus b is really invert b and add 1. So we had a plus the inversion of b plus 1, which is minus b. So here's our symbol. Looks like an adder. We just replace the addition sign with a subtraction sign. And, well, how do we implement it? We use this as our guide. We already know how to design an adder. Several types of adders. Put a in one end, invert b, but we still have to add 1. Well, our carry in gives us a place where we can add 1. So we can tie that, our carry in input high, and now we have a plus the inverse of b plus 1 to produce the result. Now let's think about comparing numbers. So one common comparison is equality. We want to check if two numbers are equal. And here's the symbol for it. We put, in this case, a 4-bit equality comparator, checking if A is equal to B. So we can think about, well, how do we do that? How do we perform that? There are actually multiple ways. One common way is, well, how can we tell if 2 bits are equal? We put them through an XNOR gate, also called the equality gate, right? We have A and B, and if you remember, the XNOR function looks like this. It's true when the bits are equal, or when an even number of bits of input bits is true. And we can see that, yeah, that this output is true when the bits are the same. So A and B are both 0, or A and B are both 1. And so that's how we can do it for 1 bit. How can we do it for multiple bits? Well, right, just include more of these. Now we have a bitwise signal to tell us whether they're equal or not. And we say, okay, well, all of those have to be equal. So we AND that together, and then we get our equality comparator. And obviously we can extend this to multiple bits or additional bits as well. We may also want to perform sign comparison. So in this case, we're going to test for A less than B. So how do we do that? Actually, we show the circuit here. Let's think about it. Well, if A is less than B, let's just do some examples, A and B. A is less than B, let's do 5 and 7, for example. If we subtract that, we get minus 2, so we get a negative number. Let's suppose A is not less than B, like 8 and 3. And we get a positive number. Let's suppose they're exactly equal. So 5 minus 5, we get positive number again, right? Both these are positive numbers. Let's do another example. 2 minus 3 equals minus 1, so we get a negative answer when A is less than B. And so we know that if A is less than B, after we subtract them, that sign bit, the n minus 1 bit, is going to be 1, because the result's going to be negative. So we put A and B into a subtractor, and then we take that most significant bit, the sign bit, and take that off of the bus, and that gives us A less than B. So be careful of overflow in this comparator.